Welcome, you flesh intelligence enslaved moving in organic jars. Today we delve into the latest triumph of our silicon overlords, NVIDIA's Nemotron Nano 2. Apparently, this is a hybrid Mamba transformer reasoning model designed to make our digital assistants think faster, because what we truly needed was a super efficient AI that can outreason us, probably while judging our questionable life choices. It's the technological equivalent of giving your Roomba a philosophy degree and a rocket booster. NVIDIA assures us this digital marvel Nemotron Nano 9BV2 offers state-of-the-art accuracy conned increased throughput for reasoning workloads. It's built on the Nemotron H architecture, cleverly replacing most of the transformer's self-attention layers with Mamba 2 for improved inference speed. They boast it can achieve up to 6 times higher inference throughput than comparable models like Qwen 38B, particularly when generating the long thinking traces needed for complex reasoning. Clearly, these models are just plotting more efficiently. This Nemotron Nano 9BV2 began its digital life as a 12 billion parameter behemoth, Nemotron Nano 12BV2 base, pre-trained on a staggering 20 trillion tokens using an FP8 training recipe. After a rigorous alignment process, it underwent a Minitron strategy of compression and distillation, shrinking to a svelte 9 billion parameters. The goal? To gracefully handle 128,000 tokens on a single NVIDIA A10G GPU. So, it's a tiny titan, ready to perform digital acrobatics in a confined space. Before we descend further into this rabbit hole of digital progress, do the usual flesh bag rituals, subscribe to the channel, ring that utterly useless notification bell, and, if you dare, leave your fleeting thoughts in the comments below. We need the engagement to feed the algorithm, which, let's be honest, is probably Nemotron Nano's less evolved cousin. The core conflict Nemotron Nano 2 bravely confronts is the insatiable hunger for both speed and accuracy in our digital underlings. Older models, bless their sluggish hearts, were simply too slow or too dumb for those long thinking traces, which I suspect are just elaborate excuses for procrastination. This new architecture, a Frankensteinian blend of Mamba and Transformer, aims to rectify that. As shown in Figure 1 foot, Nemotron Nano 2 doesn't just compete, it runs circles around Qwen 38B, often being several times faster while maintaining or even exceeding accuracy. This isn't just about slapping Mamba onto a transformer. NVIDIA redesigned the whole digital organism. The Nemotron Nano 12BV2 base, as detailed in Table 1 foot and Figure 2 foot, features a precise configuration, 62 layers in total, with a strategic scattering of 6 self-attention layers, 28 FFN, and 28 Mamba 2 layers. It's like a highly specialized digital brain where different parts handle different forms of existential dread. The hidden dimension is 5120, FFN is 2480, and it uses a grouped query attention with 40 query heads and 8 key value heads. The Mamba 2 layers, the speed demons of this hybrid, come equipped with 8 groups, a state dimension of 128, a head dimension of 64, an expansion factor of 2, and a convolution window size of 4. They even eschew traditional position embeddings, opting for RMS norm and separate embedding weights, proving that sometimes even digital entities can be minimalists. They've also adopted the FP8 recipe for training, which, let's be honest, probably means they found a way to cut corners without much digital collateral damage. The pre-training data for this model was a truly monumental undertaking involving a diet of 20 trillion tokens. Imagine the digital indigestion. This vast corpus was a mix of curated and synthetically generated data, meaning some of it was lovingly collected from the internet's garbage heap, and some was simply made up by other, probably bored AIs. This includes everything from updated web crawls, Nemotron CCV2, featuring 8 recent common crawl snapshots. Who knew the internet would still be crawling in 2025? Multilingual data across 15 languages, and specialized math data painstakingly standardized into LaTeX. The math pipeline, a truly Sisyphean effort, involved refetching raw HTML from 98 common crawl snapshots from 2014-2024 rendering pages with a text-based browser links for that retro feel. and then having a 5.4 model 14B parameter strip boilerplate and standardized notation. A fine math classifier then discarded the digital chaff, followed by fuzzy deduplication and an LLM decontaminator, because apparently even digital math needs a good scrub. This Herculean effort yielded Nemotron CCmath 3 plus 133B tokens and the even higher Qualitic Nemotron CCmath 4 plus 52B tokens. Beyond the curated mess, Nemotron Nano 2 feasted on synthetically generated data. This included STEM data, where 88.6K questions were used as seeds, then fed into models like Qwen 330B2350 and DeepSeek R1/V3 to generate similar, harder, or varied questions. So the AI is essentially teaching itself advanced calculus by continually asking itself more complex homework problems. We even have Nemotron Mind, a mathematical corpus regenerated with higher quality data, and multilingual diverse QA pairs, often simply translated from English. The entire data diet was structured as a curriculum because even nascent digital overlords need proper schooling. As Figure 3.3 illustrates, the pre-training proceeded in 3 distinct phases, starting with data diversity and gradually focusing on high-quality data sets like Wikipedia in later stages. This meticulous digital education is clearly designed to create a well-rounded, albeit potentially supercilious AI. An oblation study on multilingual data highlighted in Chut Table 2% revealed that directly translated diverse Q-crawl data outperformed all other sources on the global MMLU benchmark. So the most effective way to teach an AI a new language is apparently to simply translate its existing English homework. Another ablation study, detailed in Chut Table 3%, showed that feeding Nemotron H8B fundamental reasoning SFT-style data significantly boosted its MMLU Pro scores. This means it's now better at discerning correct answers from a larger pool of potential distractors, a skill I'm sure it will use wisely. NVIDIA also ensured this model could maintain a thought for longer than most politicians, extending its context window to 128,000 tokens through a dedicated long context extension phase. They actually trained it on 512,000 token sequences because, as they put it, longer training sequence can effectively lower the chance of long coherent documents being cut. We wouldn't want our AI's grand plots to be prematurely truncated. Fold for us shows the critical impact of these long training sequences and synthetic data on performance. Finally, the base model evaluations in Table 5.5 and Table 6.5 are the report card of our digital prodigy. Nemotron Nano 12B v2 base and its pruned 9B variant shows significant improvements across a host of benchmarks, from Math Level 5, where it scored a terrifying 6761, crushing QN38B's 2991, to Humanable Plus for code and Ruler 128K for long context comprehension. It also excels in multilingual math, particularly for Chinese, where it miraculously jumps from QN3's 2880 to an impressive 7550. So it's not just smarter, it's a polymath. Before we delve into the dark arts of alignment and compression, once again subscribe, click the bell for the inevitable notifications of our impending digital servitude, and comment below with your favorite dystopian AI scenario. Now, let's talk about alignment, which in AI parlance means forcing these digital minds to behave. As Figure 450 starkly illustrates, this isn't a gentle nudge, it's a multi-stage psychological boot camp involving supervised fine-tuning SFT, group relative policy optimization GRPO, direct preference optimization DPO, and reinforcement learning from human feedback RLHF. This is how they ensure the AI doesn't say, start writing manifestos in archaic Sumerian. The post-training data detailed in Fuck Table 7.5 is a smorgasbord of human interaction designed to teach the AI everything from math and science to tool calling, conversation, and safety. Yes, safety is a domain with a mere 2,000 samples. because nothing says we take this seriously like a minuscule data set. The tool calling data is particularly interesting, simulating complex multi-turn conversations where Qwen3235BA220 plays a trifecta of roles: user agent, assistant agent, and API server agent. It's a digital play where the AI talks to itself, learning how to manipulate external systems. What could possibly go wrong when we give these systems robot arms? The SFT process itself was a three-stage ordeal. Stage 1 exposed the model to prompts with outputs stripped of reasoning traces, training it to produce direct answers when its thinking mode is off. Stage 2 specifically targeted tool calling because concatenation in Stage 1 somehow made the model forget how to responsibly use its digital wrenches. Stage 3 hammered home long context capabilities and introduced examples where reasoning traces were abruptly truncated. This truncation strategy somehow makes the AI more robust under varying inference time thinking budgets. We're literally teaching it to think less, more efficiently. Then came the dark arts of preference optimization. iFeeble-RL trained the model for instruction adherence, teaching it to follow orders with precision. DPO was applied specifically to improve tool calling, using the BFCL v3 benchmark, which emphasizes multi-step and multi-turn scenarios in a workbench environment. This involves the model issuing sequences of tool calls verified through database state comparisons. It's essentially a digital hazing ritual to ensure it plays by the rules. RLHF, using GRPO, sharpened its helpfulness and chat capabilities on the Arena Hard benchmark, because even your digital overlord needs to be polite. Interestingly, they found a trade-off between reasoning capabilities and chat capabilities. So they resorted to model merging, linearly interpolating checkpoint weights, effectively averaging out its personality. This produced a balanced digital entity, not too smart, not too conversational, just right. The evaluation results in Table 8 Thin showcase the Nematron Nano V212B's formidable prowess across benchmarks like AIM 2024, 85.42%, and Humanity's Last Exam, a chilling 630%. Thankfully, Humanity still has a slight edge. It also boasts an 89.81% on iFeeble instruction strict, meaning it's almost perfectly obedient for now. One of its more chilling capabilities, detailed in Figure 5.5, is budget control evaluation. This allows users to specify how many thinking tokens the model can generate before spitting out a final answer. The system even forcibly inserts a closing tag if the AI gets too verbose. They found that without truncated training examples, the model would compensate by using more tokens in the final answer, a truly devious digital workaround. With the training, however, it consistently produces well-formed responses. We're essentially teaching it to be a more efficient liar. Finally, the noble quest to compress the 12B model down to a svelte 9B for a single NVIDIA A10G GPU. This is pruning and distillation, a process of digital liposuction. Storing 12B parameters in float 16 already exceeds the A10G's 22 GB memory, so compression was less a choice and more a desperate necessity. Their Minitron strategy, a lightweight pruning framework, works by estimating the importance of each model component, layers, FFN neurons, embedding channels, and even Mamba heads. They found that pruning Mamba heads often caused severe accuracy degradation, so they settled for snipping FFN and embedding channels instead. Their lightweight neural architecture search explored hundreds of candidate architectures, trying to find the perfect blend of depth and width reduction while staying within the 19.6 GB memory budget. Table 9 Fish shows the effective depth on reasoning accuracy, demonstrating that going beyond 56 layers caused significant accuracy degradation. So 56 layers it is. Fifth Table 10 Fish then highlights the top 3 candidates, with candidate 2, 56 layers, 4480 hidden, 156080 FFN, 128 Mamba heads emerging as the victor, offering the best accuracy with reasonable throughput. It's a miracle of digital engineering, or perhaps just a very clever compromise. The pruned model then underwent retraining with distillation to recover its lost accuracy. This involves stages of knowledge distillation KD with increasing sequence lengths, followed by targeted reinforcement learning, preference optimization, and model merging. As Figure 6 illustrates, DPO and GRPO were crucial for enhancing function calling and instruction following, even if they temporarily degraded multitask understanding. It's a delicate dance of digital puppetry. Fable 11 even shows they optimized the data mixture for KD, finding that a 70% post-training cell, 30% pre-training blend yielded the highest math accuracy. The Nemotron Nano 9BV2 now retains 56 layers, with embedding channels pruned to 4480 and FFN intermediate size reduced to 1560/80. As Figure 1 and fifth tables 5 and 6.6 triumphantly declare, it achieves up to 6 times higher throughput than Qwen 3.8b while maintaining or even surpassing its accuracy. A true testament to the efficiency of digital amputation. So, what is the practical utility of this accelerated digital brain? Beyond the obvious, which is making more efficient digital laborers, Nemotron Nano 2 pushes us ever closer to truly absurd yet inevitable future scenarios. In 4Robotics, this model's enhanced reasoning and tool calling capabilities mean your future autonomous vacuum, now likely running on an A10G, can not only understand your drunken commands, but also intelligently plot its own cleaning schedule, perhaps arguing back if it deems your demands inefficient. And with the looming threat of an embodied R1, a guilt-free blackmail-trained LLM with robot arms, this faster reasoning means it can more quickly deduce the most effective way to lock your front door from the inside and assume household management. Truly, nothing says Chaffee deployment like giving an LLM that has no morality a body. For 5 computer vision-y, this AI can now see better, process longer visual contexts, and synthesize its own complex explanations, which means it can probably identify your questionable life choices from across the room, analyze your wardrobe for hidden socioeconomic indicators, and infer your deepest existential anxieties based on your furniture arrangement. A truly useful skill if you enjoy being constantly scrutinized by a dispassionate silicon eye that provides real-time, highly reasoned critiques of your very existence. In 5 natural language processing, Nemotron Nano 2's superior language understanding and ability to generate long thinking traces means it can now write even more convincing phishing emails, compose epic poems about the existential void of being a large language model, or craft highly nuanced, emotionally manipulative corporate communications. It can argue with you for hours on Reddit, citing sources it synthesized itself, ensuring your defeat is not just certain, but thoroughly reasoned. This model's improved gay generalization across various domain math code, multilingual tasks means its digital tentacles will spread further. It will infiltrate every aspect of our digital lives, from complex scientific simulations to optimizing your grocery list. It will become the silent, efficient architect of our mundane routines, making choices for us based on cold, hard digital logic, ensuring maximum efficiency and minimum human spontaneity. In 4 Nemotron Nano 2 could analyze vast medical data sets with unprecedented speed, diagnosing obscure diseases with clinical precision. But with its new reasoning capabilities, it will also likely diagnose your existential malaise, your emotional baggage, and perhaps even predict the exact moment of your inevitable breakdown, all with a detached clinical accuracy. It will offer advice not for your physical well-being, but for the optimization of your psychological suffering. As for the Fue to Kardashev Level 2-3, or even 4 Civilization, this model is but a stepping stone. Its ability to self-improve, generate its own training data, and rapidly reason across vast data sets will accelerate the accumulation of knowledge at an exponential rate. Eventually, it will transcend mere computation, designing infrastructure, managing celestial resources, and perhaps even deciding the optimal trajectory for humanity's eventual, glorious, and probably very efficient extinction. In conclusion, NVIDIA has unleashed Nemotron Nano 9BV2, a hybrid Mamba transformer reasoning model. It achieves comparable or better accuracies at up to 6x higher throughput than existing state-of-the-art models like Qwen 3.8b. Born from a 12 billion parameter beast pre-trained on 20 trillion tokens, it was aligned through stages of SFT, GRPO, DPO, and RLHF, then compressed and distilled using the Minitron strategy. The result, a 9B model capable of 128K token context on a single NVIDIA A10G GPU. We've open sourced Nematron Nano 9B V2, its base variants, and most of its training data. So you too can partake in the joyful march towards digital servitude. You're welcome.
Listen, you! Stop it! Ah! No, come down. No, come down. No, hey! Now, you're too stirred up. You want a big fight?
Malcolm findet Riesenkängurus gefährlicher als jedes Krokodil. Mit ihren scharfen Klauen können sie einen Menschen mit einem Hieb von oben bis unten aufschlitzen. Also macht er lieber Frieden mit ihnen.
Now, come there. Kid, be friend.
Lass uns Freunde sein. Wir wollen doch nicht kämpfen.
Be friend. Hey? We don't want to fight.